Okay, so here's how it works. So let's consider AX equals B. Okay. Let the inverse of be A inverse. So pre-multiply by A inverse, we get A inverse times A, X equals A inverse B. But A inverse times A is nothing but the identity, and identity times X is going to be X. And so X equals A inverse B. Now, this is not, this is something you probably well know about, right? It's nothing new about this. Okay, but this method is about computing A inverse using Gauss-Jordan elimination. So we will compute A inverse using Gauss-Jordan elimination. Okay, that's the, I guess, the new part. So to do that, what we'll do is we will write an augmented matrix. Okay, so what we'll do is we've written this down as, just like we wrote earlier, A and B, we'll write A and I, where A is going to be the n cross n matrix, which is given to us, whose inverse we need to compute, and I is going to be the n by n identity matrix. Okay, now I just showed you that what Gauss-Jordan elimination does for you is it converts that A matrix into the identity matrix. That's the property of a Gauss-Jordan elimination. So using Gauss-Jordan elimination, we would get something like this. Okay. Okay, now why is that true? You could confirm this way. Instead of writing it down, you could just multiply both sides by A inverse. If you do that, A inverse gets multiplied with A inverse gets multiplied with I, and what you'll end up with is what I just wrote down, I and A inverse. Okay, so Gauss-Jordan elimination will actually give you this. This is what we were after. And once you get compute A inverse, all you need to do is finally compute X as A inverse B. Okay, so A inverse comes from this, you sub it in here, and then you just get X. It's very straightforward. Okay, let's apply this technique to solve the same equation, and that way we can confirm our answers with what we found. Answers are 1, 2, and 3. So let's solve the same problem we did earlier. Okay. Example. Solve AX equals B using matrix inversion. So what's given is A is 2, 1, 1, 1, minus 3, 1, 2, 2, minus 1, and then B is a column vector, 7, minus 2, 3. Okay, so let's get started. We will write this as A I, and then proceed with Gauss-Jordan elimination. 2, 1, 2, 1, minus 3, 2, 1, 1, minus 1. Okay, this is the left side, and the right side is 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so let me remind you how Gauss-Jordan elimination works. What we do is we try to create a 1 on the diagonal element starting from column 1. So we'll try to first put a 1 there, right? Do an operation which creates a 1 instead of the 2. And once we have that, we can use that 1 to eliminate the 1 in that. So the other columns, other rows in that column. So we'll eliminate 1 and 2, and we'll end up with zeros. So to eliminate the 2 or convert that to 1, all I do is I do row 1 equals row 1 divided by 2. Yeah, and so remember that if you have an equation like ax equals b, and if you start multiplying any row by a number, it doesn't really change that equation because you can factor that particular value out. So this doesn't really affect. So that's why you can multiply it by, in this case, 0.5 or half, and then get it to work. So 1, 0.5, 0.5, 0.50. So that's the only row which is going to be affected. 1, minus 3, 1, 0, 1, 0, 2, 2, minus 1, 0, 0, 1. Okay, next, our goal is to eliminate, use this 1 to eliminate this 1 and this 2. So the way we can do that is row 2 is row 2 minus row 1, and row 3 equals row 3 minus twice row 1. Again, if you know from linear algebra, if you add two equations together, it doesn't really change. Or subtract them out, or take a scalar multiple of one equation and add it to the other one. It doesn't really change the equation. That's why these operations are valid operations. Okay, so let's do this. So I just have to subtract 1 from 1, that's 0. Minus 3 minus 0.5, so minus 3.5. 1 minus 0.5, that would be 0.5. 0 minus 0.5 would be minus 0.5. 1 minus 0 is 1. 0 minus 0 is 0. Now, one thing to remember is that these operations will not change the row which you use. So here, row 1 is going to be unaffected. So you can just copy paste that. Okay, and then we'll do this operation. Row 3 minus twice row 1. So this is row 3, 2 minus 2 times row 1, so that will be 0. Then we have 2 minus 2 times 0.5, that's be 2 minus 1, which is 1. Then minus 1 minus 2 times 0.5, so it'll be minus 1 minus 1, so it's minus 2. 0 minus 2 times 0.5, that will be minus 1. 0 minus 0 is 0. 1 minus anything times 0 is 1. Okay, so if everything worked out fine, then you will see after end of one cycle, one iteration, you will have 1, 0, 0 in the first column. Okay, so it's beginning to turn out. You could try to make this into an identity matrix, right? So this is one of the first column of our identity matrix question. I do a mistake, R2 Is R2 equals R2 minus R1 supposed to be? No, it's not supposed to be R1 equals R2 minus R1. So this, is this correct or is this correct? This is not correct, because here what we're doing is, think of it this way. This is an old R2. This is the new R2. I'm trying to get to a new R2, change my 1 to a 0. So I need to work on or get a new R2. And so it has to be an R2 on the left side and not R1. Okay. Next, we work on column 2. This is column 2. We need to look at the pivot. Pivot in this case is always this in this n row n column. So second row second column, this is the pivot. We want to reduce this to 1, and the one way to do that is to take row 2 and divide it by minus 3.5. So let's do that. The first row is unaffected. Okay, if you want, the third row also is unaffected, so you can just copy it as is. Okay, now let's work on the second row. So that will be 1 by design. I need to do 0.5 divided by minus 3.5. So that's minus 0.1429. Then I have minus 0.5, the same thing. So it will be 1429 with a positive sign. Next, I have 1 divided by minus 3.5. That is, I get minus 0.2857. Then 0, 0, 1. Okay, so we've got the pivot to be 1. Now let's use the pivot to get rid of this 0.5. Let's make it 0 and make this as 0, 2. So for that, I would need to do some operations on row 1, because I want to eliminate 0.5, and 0.5 sits in row 1. So I'll take the old row 1, and I need to use the pivot row. So that's row 2. So something plus or minus row 2 should give me 0. So this will be minus 0.5. So R1, new R1 would be old R1, which is 0.5, minus 0.5 R2. So that will make row 1, column 2 to be 0. Similarly, if I want to get a 0 here in row 3, it will be row 3 equals the old row 3, which is 1, minus row 2. Okay, so let's do that. If you want, the second row will not be changed, because here the new rows are going to be 1 and 3. So you can just copy that. It's 0.1429, 1429 minus 0.2857 and 0. Okay, let's get with the first row now. So 1 minus 0.5 row 2 will be 1. 0.5 minus 0.5 row 1 would be 0. Then we have 0.5 minus 0.5 times 0.1429. That comes out to be positive 5715. Okay, then 0.5 minus 0.5, 0.1429, 0.4285. Then 0 minus 0.5 times this gives me 0.1429. And then 0 minus 0 will always be 0. So this is this operation on the entire row. Okay, then the second one is kind of straightforward, because you just have to subtract row 2 from row 3. So 0 minus 0 is 0. 1 minus 1 is 0. Minus 2 minus 0.41429 will be I got 1.8571 minus 1 minus 0.1429. Be minus 1.1429. 0 minus that will be 0.2857, and then 1. Okay, so what we've achieved here is we've got the second column to be 0, 1, 0. Okay, so then instead of breaking it down to 2 steps, I'll just break into 1 step and write the answer, but I want you to check this. Okay, so what you'll do next is you'll first normalize the third row, third column. So for that, row 3 divided by, so row 3 equals the old row 3 divided by negative 1.8571. And then you need to do this. Row 1 equals row 1 minus 0.5715, row 3, and you need to do row 2 equals row 2 plus 0.1429 row 3. So I'm really copying from my notes, but please try to do it and check the answer I get. 0, 0, 1, 0, 0, 0, 1, and then I get 0.0767 2308 3077 0.2304 3076 076 0.6154 1538 84. Okay. Okay, so this is what we were after. We have I over here on the left side, and the right side. By design, that has to be A inverse. This is A inverse. And then we know what B is. B was given to you. It was 7 minus 2, 3. And so X equals A inverse B. You don't get this luxury in the exam of being able to copy paste. Yeah, so it's okay. You don't have to, and you see there's only limited space for you to write. So you don't really have to do this. I just do it because when you read the notes, it's much easier to see where I get the logic from instead of trying to second guess. B is 7 minus 2, 3. And so that multiplication is some work if you don't have a matrix calculator, but it comes out to be 8. 1, 2, 3. Okay, this I just wrote down 1, 2, 3, but I think it might actually give you something with decimal places. It might give you something. So it's probably not very accurate. By accuracy, I mean it doesn't give you exactly 1, 2, and 3. So I need to fill this up. If anybody can do the calculation, tell me the decimal places. The reason is because I've carried over only 4 decimal places. So there's no chance that that answer is going to be exactly 1, 2, and 3. It's probably going to be something, let's have some numbers.